Hello, my name is Michael Bassett, and this is my video submission for um, the third AI assignment. I'm using ChatGPT 3.5, and I'm solving problem 11-9 from the Hibbler book, Solid Mechanics. So in order to begin, what I did was I specified, or what I'm trying to find is the lightest W360 shape section that I can use, given that the allowable stress is 150 megapascals and the allowable shear stress is 80 megapascals. So what I did was I used ChatGPT to solve for the maximum bending moment, because that's what we need in order to solve for the section modulus to determine what the lightest W360 shape section we can use. So I first specified what I needed, or what was on the beam. So I said it was 6 meters. There's a fixed wall support at x equals 0. This is not entirely true. However, if I were to do a pin support, it would only do one direction. I don't know if the data bank that ChatGPT gets its data from is flawed. It also said that something else earlier on, which I've got so much of this, I've been working for hours on it, but I don't know if the data bank is wrong or something, but I had to use this in order to get both a horizontal and a vertical reaction, but I understand this is wrong. Simple support at x equals 4 acting upwards. It also has a point load of 50 kilonewtons acting downwards at x equals 6. There's a uniform distributed load of W equals 40 kilonewtons per meter acting downwards from 0 to 4, and W equals 0 from just after 4 to 6. So I asked it to do this. It did a summation of forces in the y direction, upwards at AY, which is the vertical support at x equals 0, and BY, which is the vertical support at the simple support at x equals 4. Downwards distributed load, and the point load acting downwards. And then it did a summation a moment about the fixed end, about point A in this case, or x equals 0, a clockwise moment from the point load, a counterclockwise from BY, and a clockwise from the distributed load, which is all correct. It ended up getting AY plus BY equals 210. And from the sum of moments, it got BY equals 155 kilonewtons, which is correct. And then substituting back into this equation, it got AY equals 55 kilonewtons. Therefore, AY equals 55 kilonewtons and BY equals 155 kilonewtons. And I have my work here. So to compare it, I did the exact same analysis, AY at x equals 0, BY at x equals 4. The distributed load can be simplified into a point load, 160 kilonewtons acting at 2 meters, so half the distance, 40 times 4, which was represented by the integral over here to get 160 kilonewtons acting downwards. I did the exact same equation, got AY plus BY equals 210, and then the moment equation about A, I got the clockwise moment from here, the counterclockwise from BY, and the clockwise from here to get BY equals 155 kilonewtons and AY equals 55 kilonewtons. So then I asked ChatGPT to cut the beam at x equals 4 and solve for the internal forces and moment at this point, and only to consider the left side. So it cut the beam at x equals 4, and it found that the vertical, or the shear force, at 4 is negative 105 kilonewtons, and at 4 the bending moment is negative 100 kilonewton meters. So comparing it to what I have, I said from A to B, W equals 40 kilonewton meters. From the shear force at A, which is just this upwards force here, to some function Vx equals the negative W from 0 to some point x dx. I got that to be negative 40x from the integral, plus VA, which is 55 kilonewtons, as you can see here. And then the moment is just the integral of that. So I got negative 20x squared plus 55x from this integral here, and MA is equal to 0, as we can see from this equation right here. So checking in with ChatGPT, it got V4 equals negative 105 kilonewtons, M4 equals negative 100 kilonewton meters, which, to compare it here, sorry about that. So this is from 4 to 6. I did the right side. It did I asked it to do the left side because when I asked it to do the right side, it had some issues. And I got that the moment about B is equal to negative 100 kilonewton meters. So V4 equals negative 105 kilonewtons, which is correct because if you can see on my shear force diagram, you see that at x equals 4, it actually experiences an undefined slope. It goes all the way up. So to x equals negative, or I'm sorry, to x equals 4, at x equals 4, V equals negative 105 kilonewtons. However, from just after 4 to 6, V equals 50 kilonewtons, which you can get from this cut of a beam, which if you were to do the reaction forces, you would see that the shear force here would be the opposite of this negative 50 kilonewtons, which would be positive 50 kilonewtons, which is what I got here. And then taking the integral of that, you get 50x minus 100 kilonewton meters. So going back to Chat GPT, we can see that it got the negative 105 for at x equals 4, which is correct. And the moment at 4 is negative 100 kilonewton meters, which is also correct. So then it was doing some incorrect calculations. It was trying to take the shear from the right side and trying to do by minus p. It also was erroneous because it tried to consider by as in the interval from 4 to 6, as seen by this integral. It tried to integrate by, but it's not in that interval from 4 to 6, so I called it out multiple times. And so it calculated the moment finally when it just got to V of 6 equals 50 kilonewtons. And then it calculated M of 6 to be at 100 kilonewton meters. And I asked it to include the initial condition when it calculated M of 4 equals 100 kilonewton meters. So it did that. And it did an erroneous calculation here when it finally corrected everything. 50 times 6 is 300. 50 times 4 is 200. 300 minus 200 minus 100 is not 100. Call that out for the bad subtraction. And it got M of 6 equals 0 kilonewton meters, which is correct. And then it took into account all the given information and calculations and got this. And based off of all of these potential maximum moments, it determined that negative 100 kilonewton meters was the true maximum moment. I tried to do it again to see if I could get a cleaner try with this, but that ended up not happening. So then I asked it to calculate the section modulus. So using M equals 100 kilonewton meters, we only need the absolute value, the magnitude of that moment. And the allowable stress is 150 megapascal. So for section modulus in terms of meters cubed, you need to specify that or else the calculations are going to be really wonky. So it knew that the section modulus is equal to the bending moment over the allowable stress. It calculated that in terms of meters cubed, the section modulus is 1 over 1,500. I asked it to convert it into millimeters cubed. It erroneously tried to cube everything, which is not correct. It's only supposed to cube this 1,000 millimeters. That's just correct dimensional analysis. But it got a wrong answer. Told it how to multiply it correctly, to which it got 666,666.6 repeating millimeters cubed. And then I asked it to convert it into scientific notation, which it got 6.6 repeating times 10 to the 5th millimeters cubed, or 666.6 repeating 10 to the 3rd millimeters cubed. And that's important because if you look at Appendix B to try to get the lightest W360 shape, we know that the right answer is W360 by 45. This is the column of section modulus. We want the XX axis. We want it to be cut in. We want it to cut the I bar in half horizontally. So this is the section modulus we want. We can see it's in 10 to the 3rd millimeters cubed. So that's why it's important to call it 666.6 repeating. And as we can compare to all of the section moduli here, we see that 578 and 475, that's below. Those are not safe. It will not be able to handle the stresses. And everything above can, but it's not the lightest shape. So from this, we see that the correct answer is 688, the W360 by 45. And looking at my work, I also did the same calculations. The maximum moment, as you can see from my bending moment diagram, negative 100, took the absolute value of that, 100 kilonewtons per meter, multiplied by 1,000 to get it to Newton meters, and then 150 times 10 to the 6 pascals, but I just simplified that to its base terms, newtons per meters squared. Got 6.67 times 10 to the negative fourth meters cubed. This is why it's only supposed to multiply the 1,000 to the third power, is because these meters cubed will cancel out, and then you'll have the 1,000 cubed millimeters cubed, which gets you 667, essentially, times 10 to the third millimeters cubed. Therefore, from Appendix B, W360 by 45 is the lightest W360 shape. So yes, that is my analysis.